Okay folks, here's some revision on lesson 3, which is TARS mechanics. You're going to learn about the mechanics, robot assistant TARS. We're going to learn about the term acceleration. We're going to draw on your knowledge. You should all know that speed equals distance divided by time, but I want you to be able to rearrange that equation. So using this triangle here, speed equals distance divided by time. Distance equals speed times time. Time equals distance divided by speed. So there's also going to be another equation for acceleration, and you should be able to calculate acceleration and the other things that are in this equation. So here's some TARS modes here as it's moving. So as TARS is walking, the distance it can cover is calculated by the speed. So in this question here, TARS walks for 20 seconds across the surface of Dr. Mann's planet at 2 meters per second. So that means every second it travels 2 meters. That's a speed, 2 meters per second. And the time, which is always in seconds, remember we've been doing that quite a lot. The time it travels, the time it takes is 20 seconds. So how far will TARS travel? How far? The distance. So distance equals speed times time. We have the speed, which is 2 meters a second, and we have the time, which is 20 seconds. So it's just as simple as 2 times 20 equals 40, and remember your units, it's in meters, and remember you have meters in here anyway, so that should be the giveaway. 40 meters TARS will travel in 20 seconds, travelling at 2 meters a second. Now, if its speed increases, so back here it was travelling at 2 meters a second, what if it increased its speed up to 4 meters a second? Its speed has doubled, but if a speed increases like that or decreases, that is known as acceleration. Not all cars travel at 30 miles per hour, they might go up to 70 miles an hour on the motorway, so to be able to do that, the car has to accelerate. So acceleration is known as the rate of change of speed per second. So again, if you're driving through Livingston, the speed is around 30 miles per hour. You enter a motorway, you would want to increase your speed to 70 miles per hour, and to be able to do that you have to accelerate. So here is the equation for acceleration. Acceleration, which is a small a, equals v, which is the final velocity. Velocity is just another word for speed. So it's your final speed or final velocity, take away your initial velocity or speed, so the speed you started at, all divided by the time it took, which is in seconds. And acceleration is measured in meters per second per second. So every second your speed increases by a certain amount, every second. So just to repeat what I just said there, that every second the speed or velocity increases by a certain amount. So if you have an acceleration of 10 meters per second squared, that's an increase in 10 meters per second every second. So if you're going for 3 seconds, you would get up to 30 meters a second, because it's 10 meters per second every second. Okay. Right, we've got a table here, so you will have to use this equation and rearrange it. So in the top one you have to calculate the acceleration using this equation up the top. You will also do that with the bottom one, but the 4 in between you need to calculate the final speed, which is v, the initial speed, which is u, and the time, which is t on the bottom, and then fourth one down again you need to calculate the final speed, which is v. So how are we going to do that? So we're going to do this top one here. We're going to work out the acceleration. We have the final speed, we have the initial speed, and we have the time. So using this equation up the top here, you always write the equation out first. Acceleration equals v minus u over t. So the final speed take away the initial speed divided by the time. So the final speed is 30, the initial speed is 20, and we divide that by the time, which is 10. Always do the top part of the equation first. So 30 minus 20 is 10, divided by 10 equals 10 divided by 10 is 1, and the units for acceleration is meters per second squared, ms to the minus 2. So the answer in here would be 1. Hope that's okay for you all. Yep, just going to erase that out. So that top one is 1. I'm going to skip the middle 4 and I'm going to go on to the bottom one because that should be nice and easy. We're calculating acceleration again. Acceleration equals v minus u over t. And you might have noticed that the final speed and the initial speed are both the same number. That should be triggering something in your mind. If your initial speed is 42 and you're staying at 42, you can't be accelerating. Divided by 6, so that would be 0 divided by 6, which is just 0. So if you're staying at the same speed, you cannot be accelerating, you cannot be decelerating, which means slowing down. You're just going at a constant speed. So the answer in that bottom one is just 0. Right, time to do some of the middle ones. Alright, let's go for this second one down here. So we're trying to calculate the final speed. You may have noticed the acceleration is a minus number. The minus number means that it's decelerating, so the object is slowing down. Same with this one here. If it's a minus number, it's slowing down, decelerating. If it's a positive number like these 3, then it's speeding up or accelerating. Right, so we're doing the second one. A equals v minus u over t. A is minus 1.8 equals v, which we're trying to calculate, minus u, which is 100, divided by 50. How are we going to calculate u now? The first thing I would do would be move the 50 over here. The 50 is dividing on this side, so when you move it across, it's going to be timesing. So it's going to be 1.8 times 50, which is 90. So 90 equals 90 equals v minus 100. Sorry, that should be minus 90 because it's 50 times minus 1.8, so that should be minus 90. So what number do you need to take away from 100 to get minus 90? So v equals, to rearrange that, so that is 10. 10 minus 100 equals minus 90, and final speed is always in 10 in meters per second, ms to the minus 1. So that's 10 ms to the minus 1 in there. second one done. Just rub this out. So now we're going to go on to the third one. We have the acceleration, we have the final speed. This time we're going to try and calculate the initial speed, and we have the time. So acceleration equals v minus u over t. The acceleration is 3 equals 75 take away u divided by 20. So again, I would move this 20 up over here. It's dividing here, so it's timesing when you move it across. So 3 times 20 is 60 equals 75 minus u. So 75 take away what gives you 60. So 75 take away 15 gives you 60. So that'd be 15 meters per second to the minus 1. So that would be 15 in there. That's another one done. Just rub that out. Right, next one, we're trying to calculate the time. We have the acceleration, final speed, and initial speed. So acceleration equals v minus u over t. Minus 2 equals 128 take away 256 all divided by t, which we're trying to calculate. So again, if we move that t over there, minus 2t equals 128 minus 256 is minus 128. So when you move that 2 over, it's timesing on that side, so it has to be dividing. So it's minus 128 divided by minus 2. So 128 divided by 2 is 64. And the time is in seconds. So 64 seconds in there. Right, last one. We've got the acceleration. We try to calculate the final speed. We have the initial speed, which is u, and we have the time, which is 1,000 seconds. So again, A equals v minus u over t. That's 100,000. 2, 3 equals v, which we're trying to calculate. Take away 2 times 10 to the 8. All divided by 1,000. Again, move the 1,000 up here, dividing on this side, so it must be timesing. So that should give you 1 times 10 to the 8 equals v minus 2 times 10 to the 8. So when you move that over, you have to add them together. So v equals 3 times 10 to the 8 meters per second. And 3 times 10 to the 8 is the speed of light, which we'll learn later on. The speed of light all travels at that speed, 300 million meters per second. So that's the answers to them all. They're also in that table there. So just to look back in our learning intentions, we've learned about the term acceleration. We've did speed, distance, time, and we've also done the equation for acceleration, and we've rearranged it, and we've calculated some things in it. So what I would like you to do now is go to your OneNote. You have 8 questions in there that you need to complete. There's enough space in the text box. If you need to insert pictures of your equations, you're more than welcome to do that. And that will be due by the end of the week. Good luck.